So, ladies and gentlemen, I want to welcome all of you today. We are moving away from linear to fractional. We are moving away from whole numbers we are moving away from counting numbers to whole numbers. So the first question I want to ask you is, what is an integer? You can tell me, what is an integer? Moses.
So please, an integer is a negative or a positive whole number. For example, 1, 2. Yes.
This is good. Which of these are we going to consider? Is it a negative one or the positive one? Which of them are we going to look at today? He says an integer is a negative or a positive whole number. Which one are we going to look at? Bernard.
Please, the positive whole numbers.
Okay. Guys, remember that at some point in time, I will stop and I'll give marks to those who are commenting a lot. And I know everybody who is commenting. Not one in a blue moon. Not twice. Those who are persistent, especially you are commenting 3 times. Because I can't remember those who are giving 1. Okay, so we're going to look at positive whole numbers. Why? Do you remember? We didn't look at it, but let me just show you something. Let me show you something here. This is the result. I've actually done a recording of this on the page because we looked at the story of the Amabenyuado investment. But this one is on TV, radio, and newspaper, commercials. And when you look at the final value, do they make sense? And tell me why they make sense or why they don't make sense. When you look at the final value, do they make sense or not, and why? You can tell me. This is where you see, at this stage, wherever you are seated, you got to have a concentrated mind. You must have a book. You must have a pen. You must follow me in toto for the next 2 hours. You got to dance with me. That is when you understand. But when you are doing something, taking care of children, cooking and all of that, and then you say that, Doc, I don't understand, the 10 was too fast. It's because you yourself, you haven't paid that attention. So I beg you, put everything aside for me for the next 2 hours. Everything, yes, everything. Stop. Sit in front of a table. Sit on a chair. Have a pen. Have a book. Have a calculator. Sit. Alex.
Look, it makes sense.
Explain.
It makes sense because the scenario we use, this is a monetary value. So if we are having the final values in decimals or fractions, since it's monetary value, I think it still makes sense.
Excellent. That is not correct. That is wrong. Bernard.
Please, it doesn't make sense. So for TV commercials, for example, you can either do 1 or 2. You can do 1.8 TV commercials. Same with newspaper ads. You can either do 3 or 4. You can do decimal portions of the commercials. Thank you.
Excellent, Bernard. Alex, do you understand now?
Yes, Doc.
It's like telling somebody that I want to buy 2.4 cars for a friend.
Okay.
You can't actually buy 2.4 cars. It doesn't make sense. Okay. Or you want to buy 38.56 aircraft. You can't do that. Now, sometimes people are tempted to round off.
Yeah, that's what I wanted to ask, Doc.
But, well, if it is money, you can round off. But let me just ask you. Suppose the GDP of Ghana is 80.7 billion. Well, let me put it. The GDP of Ghana is 8.1 80.1 billion. And you say that I want to round up. That would be what? 80 billion, isn't it?
Yes, please.
Yes, please.
What have you done to the 100 million? You have thrown it away.
Okay.
Can you throw 100 million away like that?
No, Doc.
So rounding off is not a very good way to actually solve decimalisms. It's not. You go and get suboptimal solution. You will even encounter something known as infeasibility, where there is no solution. Now you can't even find solution. You can't satisfy some of the constraints. For example, let's say that you are rounding off something. The thing is supposed to be greater or equal to, or let's say the thing is supposed to be greater or equal to, 10. Greater or equal to 10. And then you add a number that is 10.6. You round it up, it will go to 7. At 10.6, it will go to 12 because you are rounding it up to the nearest one. Okay. Or 10.6, it goes to 11. And in that case, what you've done is that you have punished the numbers. The solution may not work. So in short, rounding doesn't solve the problem. So we need a new programming problem. And this is known as integer programming. Finish. Doesn't understand. Now, the same thing with integer programming problem is the same as linear programming problem. In linear programming problem, there is a constraint that is automatic. What is the name of that constraint? In linear programming, there is a constraint that is automatically added. You don't even talk about it, but the person must add it by force. What is the name of that constraint? Kojo?
Non-negativity constraint.
Non-negativity constraint. Now, there is also a constraint in integer programming, which is known as integrality constraint. So we are going to now talk about linear programming and integer programming, but you should know that integer programming automatically incorporates the linear part because you must have the non-negativity constraint before you can have an integrality constraint. Write it down. See, to have an integrality constraint, you must also have a non-negativity constraint. So the two of them are together. Okay. And in the Excel, that integrality constraint, when you are looking for it, it is INT. You remember where we normally have to put in less than or equal to, greater than or equal to. There was another one which is equal to. There was another one which is INT. There was another one which is binary. Write them down, write them down, write them down. So there is a binary constraint and there's an integrality constraint. Binary constraint means that the possible numbers are how many? Binary constraint means that the possible numbers are how many? Kaswa?
There are 2.
There are 2. Now, tell me whether this is true or false. All binary constraints, oh, by the way, the binary constraints, you said the possible numbers are 2. What are they?
The 0 and 1.
Okay. Now let me go to my question now. All integer constraints are binary constraints, but not all binary constraints are integer constraints. True or false? Please don't do Lotto. If you do Lotto, you're in trouble.
So can you go over the question?
It's not for you. It's not for you. Whoever is talking now is not for you. I'm about to ask the question is for everybody. So you are raising. Class rep, are you there?
Yes, sir.
Okay. So when I give a mark to somebody, you can document and put it down.
Okay.
But will you be able to get the ID?
Not the ID, but the name, probably the name. I'll check the ID later.
Okay, you have to probably backstage the person with the ID. Okay.
Okay.
So I said that all integer constraints are binary constraints, but not all binary constraints are integer constraints. You tell me why. Tell me why you are giving that answer is true or is false.
Yeah, trial.
Benjamin Otu.
Yes, sir. Because in integer you may get negative.
I can't hear you well.
An integer you may get a negative number, but then with the with binaries, then there's no negative. It's just 0 and 1.
That is false. That is wrong. I mean, what you said is wrong. Who can tell me? All integer constraints are binary constraints, but not all binary constraints. And please remember, the integer constraint I'm talking about here is a positive integer that I'm talking about. It's not about the negative. We've already ruled out non-negativity. Understand?
Okay, sir. So good morning. With the binary constraints, it involves two variables. That is maybe 0 and then 1. But with the integer constraints, it has a restriction on it. So it can be 1, 2, 3, and so on and so forth.
So what? You just spoke, no, you left. I asked a question. I said it's true or false. Explain. Not
explain, sir. I'm saying that with the integer constraint.
What's your conclusion? What's your conclusion?
My conclusion is that with the binary constraint, it has two.
What's your conclusion?
My conclusion is that it has two.
No. What's your conclusion?
True or false? True. No. Oh, I'm confused now.
You are confused. You see, you are confused. You are speaking now. You are not thought about the conclusion. Now you are confused. Is it true?
The conclusion is... No. It's true. It's true, rather. Okay.
Very good. Excellent. That is wrong. That's why I wanted you to just take your time instead of explaining. Let's go to Theophilus Asare.
It's false. With a
Theophilus, microphone is far away from your mouth.
Is it better?
No, increase your voice.
Can you hear me?
Mm-hmm.
Okay. It's a false statement. With a binary constraint, we have only two possible values. That's the 0 and 1. But with the integer constraint, it's usually a constraint within a range. So it can be x plus y, maybe less than 10.
No,
so
you're going complex. Make it simple.
Okay, so binary constraint has two values, 0 and then 1. And the integer constraint can have multiple values from 1 to the highest level of the constraint. So it could be 1, 2, 3, 4 in that order.
1, 2, 3, 4 in that order. Is that what you said?
Yes, within the constraint given.
Are you sure it could be 1, 2, 3, 4, 5 and above?
Yes, I'm sure.
So many hands. Guys, if you think he's right, you don't need to keep your hand up. The fact that your hand is up means he's wrong. So they are telling you that you are wrong. That's why their hands are up. Masa, if they are saying you are wrong, then who am I? Your own friends are saying you are wrong. So let me go to Elliot.
Yes, sir. Please, I won't say he is wrong, okay? But just to add, just to add to, make my own viewpoint. So I would say the integer constraint goes beyond 0 and 1, but the binary constraint is limited to just the two numbers which is 0 and 1. So the statement you made is false. Rather, it should be.
I can't hear you well. Start again.
Okay, so I will say that the integer constraint, it goes beyond 0 and 1. But binary constraints, we are limited to just the two numbers which is 0 and 1. So the statement you made is false. But the statement should rather be all binary constraints are integer constraints, but not all integer constraints are binary constraints.
Good. You explained it well, but you also missed something with your examples. Who spotted that? You're right. You've missed something with your example. And when you miss something like that, it makes it all wrong for me. Who spotted that thing he missed with the example? If you don't know, just lower your hands. Aminatu.
Yes, sir. Yes, sir.
Mhm.
Please, so a binary is a type
Just
of
tell me what he
integer.
missed. Tell me what he missed
Oh,
in
what
it.
he means? I didn't get that,
Yeah,
please.
you should have gotten that before you kept your hand up. Because I'm being specific here. Let's go to Swallow. What did he miss? Swallow, your hand is.
Doc. Yes, Doc. I'm thinking it should range between 0 and 9.
Why 9?
So integer ranks between 0 to 9, right?
Why do you say 9? Yeah, spoil the matter, cry. Let's go to Augustina. Last one.
So with the integer constraint, we are saying that it's a
No, tell me
specific. It
what
must
he
be a whole number.
No. Tell me what the guy who explained it well, what he missed. If you didn't hear what he said, okay.
Okay, so I didn't really get
When
what he said.
your colleagues are talking, guys, listen to them. Listen to them. Okay. So what's the name of the guy who spoke? I want to give him the max first.
Elliot, please. Wisdom Elliot.
So Elliot, what you miss is that you said it's from 1, 2, 3 onwards, isn't it?
Yes, from 0 to maybe yes,
beyond. Because now you get the point now. Okay, you didn't mention the 0.
Okay, say yes, please.
You didn't mention the 0.
Yes, please.
Even though your statement, you said that all binaries are integers, not all integers are binary. That's correct. But then you didn't, I would have given you the 3. So you have 2 marks for that. Okay. So guys, note this. This is the basics of what we are going to do. If you don't understand this, you must understand this before we continue, because this is foundational. Integers start from 0. I mean, when I say integer, positive integers start from, 0. I mean, it includes 0. 0 is right in the middle, so it's still part of it. Okay. Now, Thelma.
Sorry, question. You just said that positive integer starts from 0, but the negative also starts from 0.
Yeah, so we can just say that positive integers are from 1, but when you are talking about integers, positive integers, you can include 0. Because 0 is in the middle, you can't exclude it from negative. So when you're mentioning the negative, you include it. And when you're mentioning the positive, you include it. Don't make it complex for yourself. You can't exclude 0. So even though I'm saying positive, I'm talking about integers. So you still can't exclude 0 because it's a whole number, and 0 is also a whole number. All right. Now, the integrality constraint is a whole number. And that is what makes this whole thing whole numbers. We are going to look at 3 types of integrality constraint. 3 types. 3. And that will lead us to something known as integer programming models or integer programming problem. First, we are going to look at the total, then we'll look at the binary, then we'll look at the mix. Guys, we have a lot to do here today. So I'm going to be a bit faster with the beginning ones because they are not too important to me. I'm more towards the latter ones. So remember, be writing as much as possible, but remember that we are going to look at the total first, the binary second, and the mix third. Now, when I say total, what I mean is that in such a model, all the decision variables are whole numbers. All of them are whole numbers. When I say integer, binary, it means that all the decision variables, they are either going to be 0 or 1. The only answer you will get for the decision variable is 0 or 1. 0 or 1. But this 0 or 1 doesn't mean anything except that it means something that is there, 1, and something that is not there, 0. So if I say that this weekend in Kaswa, was there a wedding or there was no wedding? There was a wedding. Okay, that's 1. In Latebiokoshi, was there a wedding or there is no wedding? There was a wedding. That's 1. In Sakumono, was there a wedding or no wedding? No wedding. That's 0. So the 0 here is presence. Sorry, the 0 here is absence. Write it down. And the 1 here is presence. 0 here is when the 10 is there. 1 is when the 10 is not there. Now the total, all of them are there, and all of them are not just 1. They are positive. They are all positive. Whole numbers, whole numbers, whole numbers, whole numbers, whole numbers, positive whole number. Whereas the last one, the mix, that will include, some of them will be whole numbers, some of them will be 0, some of them will be 1. In other words, some are binary, some are normal positive integers, and some are even decimals. Take note, some are even decimals, like the usual linear program. So the mixed one is really mixed. Let's take an example of one of them. This is an example. Watch it carefully. Agbala. He owns a shop. And in the shop, he uses the shop. He wants to expand by buying some machines, presses and lathes. Each press bought will increase profit by $100 or 100 cedis. Each lathe bought will increase profit by 150. So just by looking at this, you can write your Z function. Just from this statement. Who can guess what the Z function will be in this context? If I were to run the Z function, if I look at the latter part here, okay, because we are talking about profit, so obviously it's going to be maximization. So what will be the Z function? Bernard?
Please, the profit function will be Z max equals to 100x1 plus 150x2.
Exactly, 100x1 plus 160x2. Okay. So this would have been the decision, and then subject to some constraint. Now we are told that the number of machines Agbala can buy is limited. It's limited by what? Cost. That word limited implies what symbol? That word limited implies what symbol? Samuel. Woman. Nathaniel.
Less than or equal to say so. Sorry.
Oh, you got to be alert when you raise your hand then to
yes, sir.
Talk, because it looks like some of you are pressing without noticing the next one. So it has to be less than or equal. Okay. And then you have a available floor space. Okay. That available also tells you what? Constant.
It's also less than or equal to.
It's also less than or equal to. So we can actually combine these and then be able to formulate a model. So we have been told the press is that, the requirement for the floor space is this, the purchase price is this. And we are told that Agbala has a budget of 40,000. That's a budget. And then 200 square feet floor available. So who can formulate the constraint for me? It should be fast, it should be quick. Who can formulate this constraint? Abubakar, Alasan.
80,000 x1 plus 40,000.
Which constraint are you formulating?
The press.
Okay.
40,000 x1 plus 8,000, sorry, 4,000 x2 less than equal 40,000.
Huh?
8,000 x1 plus 4,000 x2 less or equal to 40,000.
You say that is what constraint?
So the press.
That is not press constraint. That cannot be press constraint. You see the way many hands are up. They want to bring you down.
What's 40,000 pieces of machines?
All right, let's go to Moses Alan.
Please, that is a budget constraint.
That is a budget constraint. I'm sorry, I can't give you. You see, my class is in such a way that you either drink deep or you taste it. So, Alan, you have 2 marks for that.
Thank you, sir.
That's what, take note of that. So watch the whole thing. Don't just mathematically formulate. Okay? Think through whilst you are formulating mathematically. Okay, now the next one is a floor space constraint. And obviously, you will all agree with me that that's going to be 15x1 plus 30x2 equal to less or equal to 200. I don't want to add that so that somebody will come and then answer it because there's an allocation, but because the person really wanted to do it. So when you actually do all of this, you're going to get that constraint beautifully like this. You're going to get the constraint. So this is the objective function, and this becomes the constraint. Now, these 2 items, are they integers or they are not integers? Presses and lace, are they integers? Yes. If you want to see presses and lace like Nika something, you will not get 2.5%. So because you know they are going to be whole numbers, after the non-negativity constraint, watch what you write. This is what you write. After writing the non-negativity constraint, you will now write them again and say integer. But there's another way you can write them. After writing this non-negativity constraint, you can just add and integer. That's it. In other words, what you are saying is that these 2 that you have written are also integers. So you say and integers or and integer. That is how. So if you believe that, but if you believe that only x1 is integer, then you have to write x1 greater or equal to 0 and integer, and then x2 greater or equal to 0. If it is not an integer, you just leave it like that. Because when you leave it like that, we know that you are saying that it can be decimals. Very good. Some of you, your hands are up. Do you have a question? Do you have a question? Because your hands are still up. Isaac.
Yes.
Isaac, what's your question? You see, he's forgotten. Abubakar.
Please, just for my understanding. So at this stage, is this also a binary one?
No, it's not a binary because this, we have been told that they are there. A binary is when you have been told that you don't know, you don't have it. When we come to binary, you will understand. Don't worry. Okay. Maybe because I told you earlier, you are looking for it. Don't worry, you get it.
Yes.
Let's go to this. This is a binary, but you see, it's tricky. Legon Council must decide which of the 4 recreational facilities to build. They have to choose among pool, tennis, athletic field, gymnasium. The expected daily usage, cost, and land are all here. So this is the expected daily usage. Let me just walk you through something. So when you look at this, if the Legon Council should build a swimming pool, okay, as you can see, if they should build a swimming pool, then the people they are expecting to come and use the swimming pool are 300. The cost of building a swimming pool is 35,000. The land required is 4 acres. If they build a gymnasium, the last one, the people who will use a gymnasium are 150. It will cost 90,000 on a 3-acre plot of land. Now, when you go back to this question, it says that Legon Council must decide which of 4 recreational facilities to build. And then the expected daily usage have been given. You've also been told that the council has 120,000 budget and 12 acres of land. What does this sentence tell you? Look at the sentence. The council has 120 budget and 12 acres of land. What does that tell you? Given the table I've already shown you, what does this tell you? Moses, have you privatized the class rep so that he will give you the math? Because the way you put it here, it's like you didn't private him. I beg you, next time, okay?
Okay, sir. Thank you. Sorry.
All right. Let me go to Ishmael Sapon.
Sir, they have limited available resources.
Okay. What shows?
Sir, looking at the budget line, they have $120,000.
Yeah, but what shows in the sentence? What word? I'm helping you here. You should have given me that thing.
Sir, sir, the word here is they have.
I say what word? You are telling me using word and then you are using several sentences. Word. Mention the word. Okay, the word is has. The word is has.
Yes, sir.
That's what I needed. So that word is what tells you that it's available. Now, those of you who are writing the things on the room there, I don't know whether you think, I don't know, maybe you don't want the marks, that's why you are typing it there. But when you type it there, you spoil the whole fun associated with the marks. All right. So, what shows that this is binary? What shows that this whole story is binary? What shows that this whole story is binary? Who can tell me? What shows that this whole story is binary?
There was a statement that only one of the two can be built on the land.
Oh, no. That statement came later, isn't it?
Yeah.
But not that. That's not the one. I'm looking for, there's a word, there's a phrase, there's something. That is the clue there. Emmanuel, Calvin, Manaman. Foster, Soda.
Yes, sir. Yes, sir.
Emmanuel, why is it taking you that long to answer me?
Sorry,
Hello, sir. Hello, sir. This is Foster.
They must decide which of. They must decide which of the four. So it's a qualitative decision they have to make.
That's good. You see the way Foster wants to take the words from your mouth. Next time you do that, next time anybody does that, I won't let the person continue. You got to be attentive. The moment you raise your hand, you got to be ready that you'll be called. So your hand must be.
Yes.
No.
Yes, sir. Sorry.
Well, don't worry. It won't happen to anybody again, unfortunately. All right. So that is good. That is a good point you said. That is 1 mark. Okay? That is 1 mark for knowing. So it is that which tells you that this thing is either going to be there or not there. You don't know now. So each of them has a possibility of being built. So how do you define the decision variable? How will you define the decision variable? And if you say it in a certain way, I will know that you are copying or you are not really learning, but you are picking it. How would you formulate the decision variable? Vida Benson.
The decision variable is going to be ZMLX is equal to.
Decision variable doesn't start like that.
It's going to be 300.
Yeah. Stop. Think about it before you come back, because I think you rushed. Okay. So think about it and come back again. Decision variables don't start like the way you started. Let me go to Emmanuel Anim. Emmanuel.
Sir.
Hello, sir.
So
please,
so
S1 will be
Emmanuel Anim. Is that Emmanuel Anim talking?
Yes,
yes,
please.
this is Emmanuel Anim talking.
Hey, there are 2 Emmanuel Anim then.
Yes, Doc.
Okay. Hold on. This is interesting. I mean, I tried to mention people by their full name, but I didn't know that there are 2 names that are the same. Okay. So, the rest of you, please lower your hand. So now only the two Emmanuel and Nimsan will be up. I need to distinguish between which one of them. Because
one should be A and one should be B.
Yeah, but the rest of you, why is Elsie? Why is your hand up? And Moses, Ale, why is your hand up? Lower your hand and let me see the proper human. Because my screen is all full of hands. Swallow. Lower your hand. You are not needed at this stage. Okay, but I don't see another Emmanuel Nimsan. Only one Emmanuel Nimsan I see. Shaloretta Samuanzo. You can say lower your hands. I feel not the So, guy, I don't see the other Emmanuel Nim. The one who just came. Emmanuel Nim with the brown hand, please. I'm not calling you. Let me give it to the other. I think your hand wasn't up. So the one I will unmute. Yes, Emmanuel K and Nim. Good. You should be the one to talk. Because I think the other Emmanuel Nim sound I couldn't even see. Okay, K, go ahead.
Doc, thank you. Please. So the S1 will be the pool to build.
Again.
X1, that will let S1 be the pool that you would decide to build.
It will be what?
X1 will be the pool we would decide to build or not.
So you write the pool we will decide to build. Is that what you write?
No, the X1 is equal to pool.
If you write X1 is equal to pool, that would fail. Easy. Fail. So go and think again. I'm not giving you another chance. Go and think again. If you write X1 equal to pool, that's worse. Let me go to Kafu Mensa.
Yeah, so X1 will be whether or not.
Mensa.
Yes, please.
Okay.
Whether or not to build a pool.
That's it.
Yeah.
That's it. Okay. So X1, that's it. Very good. 2 marks for that. Okay, that is whether or not to build a pool. That makes it binary. That makes it binary. And then, of course, the other ones will follow exactly like that. That is how you document it. Okay. Now, how will you write the objective function? How will you write the objective function? Let's go back to the story here. What will you use to write objective function? Now, I'm not going to give marks to everything because some of you all have the notes already, so you can easily mention. But there are some petty things I will ask. How will you write objective function? Abubakar Hassan.
I'm going to use the expected usage people per day to write the objective function because I'm going to maximize it.
So
it will be X max equal to 300 X1. X maximum.
What is X maximum?
Because I'm going to maximize the usage.
What should I write?
So X max equal to 300 X1 plus 90 X2 plus 400 X3 plus 150 X4.
That's wrong. Next person. I have to deliberately write his mistake for him. Okay, Stina Atta.
So please, the Z max is equal to 35,000 X1 plus 10,000 X2 plus 25,000 X3 plus 90,000 X4.
Okay. So that's how it's supposed to be. That's 1 mark for you. Okay. So that is how you should formulate the objective function. Now, what will be the first constraint you want to dance with? What will be the first? Who has a question?
I
So
have a
please, are we
question.
using the usage or we are using the cost?
Using the
for
cost.
the objective
The fact that you asked me that question is an indication that she's wrong.
Exactly.
I was waiting for somebody to ask me that question, but then the fact that you've asked me that question means that she's wrong.
Yes, sir.
So that I thought that she would also say that, oh, why am I right Anyway, shouldn't say that. Because the things I've given. So that is wrong. Because what you have here, which you are using, is your budget constraint. In fact, you have a budget constraint, and then you have acre constraint or land requirement constraint. So in fact, did I even ask you what are we maximizing? I think I did. What are we maximizing? So Kafi, you are wrong. What are we maximizing?
We are maximizing the usage.
Weren't you the same person who gave that answer earlier? Or was it you, Kafi?
No, please. It was a different question.
Okay. So we are maximizing the number of people who will use these facilities. That's what you're maximizing. The number of people who use this facility. So what you got to use for the objective function. In fact, who were the two guys who mentioned the thing? I think two guys. What were they?
I did.
It was Abu Bakr Hassan and somebody else. Who was the other person?
Doc, I have a question.
Wait. Let me find the other person. And they shot. Kafi, wasn't it you?
I answered the whether or not in relating to the
decision
variables.
No, you.
Yes. So this is my second. This is my second two.
Which second two? Which second two? I'm not giving you a second two, and he said this.
On the maximization, I just responded stating that we are maximizing the usage.
Yeah, it was. So it was you and Abu Bakr whose hands were up.
Yes, please.
There were two people whose hands were up when I said the lady was wrong. Two people mentioned that.
Yes, please.
It was you and Abu Bakr.
Well, I don't know, but I know I was part of the two.
Abu Bakr, you were part, weren't you?
Yes,
please.
It's not 2 marks. It's 1 mark. It's 1 mark for detecting that. It's 1 mark.
Okay, sir.
Abu Bakr, now you can go ahead with your question.
Please, can you go back to the question? Just to understand the conditions you give that should be binary. So it must be a condition. So what if the statement was say must decide which of the 4 equation facility? So that, and that is the condition that will let you understand that decision is we make amounts them. That should be the case. There
is no other way, because you got a point. For each facility, you got to decide whether you are building it or you are not building it. For each one. So when you take pool, am I building pool or I'm not building pool? Okay, move to the next. Am I building tennis or I'm not building tennis? Okay, next. Am I building athletic field or I'm not building athletic field? Next. Am I building gymnasium or I'm not building gymnasium? You are taking them one at a go. Because it's a decision. Watch it. It's a choice you are making. Of course, it will be contingent on other things, but that is how it is as it stands. How do you understand it? Maybe you have a different understanding to it. How do you understand it? Or you thought that we need to come here before we know. We need to come because swimming pool and tennis.
Yeah, only one of the two can be.
No. Even without this condition, this is a constraint. Even without this constraint, okay? This, even if you delete this, it will still be binary. If I look at the last sentence even gives you a clue. Okay, the corporate LC wants to know which facility to construct in order to maximize the expected daily usage by the residents.
Got it. All right, thank you.
Which facility? And remember, the fact that it says which facility does not mean that you can choose not to build all. You can choose to build all. So each can be 1, 1, 1, 1, all 4 of them, unless there's another condition that prevents that from happening, which is the statement before. So those are mixed constraints. But for each one, regardless of the others, you got to make a decision whether you are building it or not. That's a standard. We'll come back to this next constraint, but for each one. Yes, go for it.
Okay, so this is just a question I want to ask. I'm a bit confused. So looking back to the investment question we tackled last week, can we also say that one too is binary because we had an amount of money and we had to invest? Can we also say that should we invest or not invest? Just as this one, we have a land and we want to build some things, and we are looking at should we build or not build. I'm just confused here.
No, that one, there was nothing of should we invest or not. That one, the money was going to be invested. Remember, he only wanted to know how much to put into what. He only wanted to know how much should I put into treasury bill? How much should I put into this? How much should I put into it? But I'm going to put in something. I'm going to do it.
Okay,
But
no, so this one to the land, we are going to use it in any way. So it's not the same. Are we
what?
going to use the land?
You're going to use what in any way? Look at the first sentence. You're going to decide, oh. It's not about use. You're going to decide.
Okay.
Watch the word. He didn't say that he has some money and he's going to build without income. No, he's going to decide.
Okay, so it could be that we will not do anything.
Also has money. And they are going to now use this money to build. No. They are first going to decide which one they are going to build. And then they'll look for the money because they even have a budget. They'll look for the money to make that. And there's something you're going to also see that will help you to know that it's binary, apart from, the decision. Watch it. There is a choice here. In the investment, there is no choice. Remember, the investment question, there was no choice. You are going to spend all of the money. In fact, at the end, the investment, we were told that Amma was going to spend all the money.
Okay. All right. Thank you, sir.
Now, the other thing is what you are maximizing. And what you are maximizing is the human beings. The human beings that will use the facility, the number of human beings. So your objective function should be 300x1 all the way up to 150x4. Okay. Now, let's go to, after this, then you have to create this constraint, the budget constraint. So this budget constraint is going to be 35K x1 plus 10K x2 plus 25K x3 plus 90K x4. And then what to be the right-hand side of that? What to be the
120K.
Sorry?
120K.
That's the resource.
Very good. That's the budget. Okay. So that's going to be 120K. That is what you are going to have. 120,000. And then the other constraint is going to be what constraint?
The land
constraint.
The land constraint.
Land constraint. And then the right-hand side will be what?
12.
12
Now,
acres.
that will mean that you need to add all this and then set it up to that one. Okay. Now, let's go to the substantive matter. It says that because swimming pool and table tennis must be built. See, some of you have got a slides, and so it makes you feel that when you look at the slides, then you are learning. You are not learning. You can put it all outside and focus on me. Yeah, then I know that you are learning. But sometimes some of the answers some of you give tells me that, you have a guide, but I want you to use your mind instead of having a guide. So let's come here. Because swimming pool and tennis must be built on the same plot of a land, only one can be built. Now, before we come to this very complex constraint, we need to look at some few things regarding constraints. Okay. So we've done all of this already. Let's look at some few things regarding the constraints. It says that because swimming pool must be built. So swimming pool is represented by what? X1. Tennis is represented by X2. What does the word all means? What does the word all means? What does the symbol all means? I'll say, anim. How many?
Plus.
It's plus. What does can symbolize? What does can symbolize in linear programming parlance? Foster. Swallow.
No, equal to.
Swallow.
Doc, I think that the can will be an option.
I said, what symbol? You say option.
What symbol? Okay.
Don't worry if you don't know. Just say you are thinking about it.
Yeah, sure.
Okay, think about it. Prince.
Less than equal to.
Why? Why is it not less than? Where is that guy? Prince, are you there?
Yes, I'm confused.
You were the one who gave me the answer and you're confused. It means you copied. This is what I mean. There are some of you copying. Put that note aside and concentrate on what we are doing. Because when you
copy.
Well, but you can't give me an answer and say that you yourself you are confused. You gave me an answer. I asked you to tell me why you say you yourself you are confused. I told you to eat. Did you eat? Okay, did you eat?
What's that?
If you ate, you won't be confused.
Yes.
So let's go to another person. Godfred.
Yes, sir. So I think it's less than or equal to, because the can here means it can be done or not, and it's not a must. Like you must not do it. It's not compulsory.
So if it is a
So
must,
I think
what?
it's greater than or equal to.
If it is a must, then is what?
Greater than or equal to.
No.
Equal to.
No. You don't be guessing. The fact that you explained it nicely, because you said that you yourself, you said that it is a less than or equal to because it is a can. Because if it has to be mass, the way you brought in the mass means that you kind of knew what it is, But then now I asked you, you are not able to tell me what it is. But you brought it. You brought the word mass, and I'm asking, mass, what should it be? Let me go to Bernard. If it is a must.
So please, must is equal to.
Okay. So mass is equal to. Can is less than or equal to. When is it less than? Everybody. Isaac Ohene is talking into the crowd. People have unmuted themselves. Should I mute them? I think I should mute everybody. So when you really want to talk, then you can unmute yourself. I can. Class rep, you can also help me unmute the people I'll call.
Okay, sir.
So when is it less than? That was my question. Bernard, when is it less than? Elsie, do you know how to unmute people?
Yes, sir.
You are not doing it for Bernard. It's like you want me to do it.
Okay, sir. Okay. So I think less than will be if it was should.
Should. Really. I'm making you a co-host, by the way.
Okay, sir.
You join me in unmuting people. No. Richard Nee, Bernard, unmuting for me. Richard. I'm about to fly now. Richard.
Yes, sir. Sir, it is less than when it must not.
Is what?
Less than when it must not.
No, that's greater. That's not equal to.
Not equal to. Okay.
You knew it was not equal to, but you are still saying it. You knew. You're still saying it. Okay. Anyway, let's continue, because I'm not going to delay much on this. So the statement also added, but not both. But not both. So it means that we are going to construct one of them, which means that when you add both of them, the word or means that you are adding both of them. Okay. And when you are adding both of them, you're going to construct. The construction means they are going to be there. They are going to be there means it's going to be equal to 1. So you have x1 and x2, okay? And if it is must be built, then it will be equal to 1. But then he says can be built. Can be built means that it should be less than or equal to 1. Now, why should it be less than or equal to 1? Because if it is less than or equal to 1, it means that either you are going to not build, either you are going to not build both of them, not build one of them, or you're going to build one of them. That's it. Either you are, so the possibility is that you will build one and not build the other. That is a less than or equal to 1. You will build one and not build the other. Now, if it was a less than 1, okay, it means you will build none of them. You will build none of them. So x1 plus x2 will be less than 0, less than 1. And if x1 plus x2, let me write, if x1 plus x2 is less than 1, it means that x1 plus x2 is equal to 0. Because the whole thing is binary. The only possible answers are 1 and 0. So if it is less than 1, then obviously it's going to be 0. So it means you are not building any one of them. Now, if it is less than or equal to, like this, it means that only one of them is going to be built. Okay? And one will not be built. Or none will not be built. So it is a possibility that either one will be built or none will be built. That's what it is. But what if it's equal to? Okay? When it is equal to, one must be built. It's going to happen. And so you got to be able to know how to reformulate this constraint. So that statement of can makes it what? Less than or equal to. Who doesn't understand? Well, this one is not the key thing for today. The key thing will come. So let's move on. Let's give it, this is called mutually exclusive constraint, by the way. But let me ask you. Breathe in. I know at this stage, some of you are not here. Some of you are in Yamanansa. So breathe in. Now, what if you have this constraint? What if you have a constraint that says a swimming pool or tennis must be built, but not both? What would that be? What would that be? Quickly. This one is done already. What would that be? Kojo?
Equal to.
Okay, equal to what is that? Okay, when you answer me like this, you make it very difficult for me to give you math. You get up now equal to. You're talking a sentence. Now you say equal, Reginald or something.
So the statement will be x1 plus x2 should be equal to 1.
Okay, so that's 1 mark there. I would have given the 2 marks if the guy hasn't spelled it. So that is 1 mark for you, Reginald. So it's supposed to be x1 plus x2 equal to 1 because we've already said that thing. Okay? It forces you. It's called multiple choice constraint. Okay, now, when you have these constraints, then you can add the usual non-negativity constraint. But let's go back to the non-negativity constraint. The non-negativity constraint is supposed to be what in this sense? In all this story, what should the non-negativity constraint be? Non-negativity constraint, Benedict Broom.
Yes, so it will be x1, x2 is greater than 0, comma, and then binary.
No, remember the entire module. You are talking about something. It looks like you don't have the entire thing we spoke about in your head. Anim, Emmanuel Anim.
So please, it's going to be x1, x2, x3, x4, should be greater than or equal to 0.
Good. That's the usual non-negativity constraint. Excellent. 2 marks. There's no doubt about that. Okay. But in addition to that, we should have the integrality constraint. I'm not asking that, I'm giving it that. In addition to that, we should have the integrality constraint, but this time not the general one, but then the binary one. So this is how you write it up. Now, there are two ways you can write this. Either you write it like what is here, or after you've written your non-negativity, okay, non-negativity constraint like this, greater than or equal to 0, then you add and binary. That's it. And binary. That's it. So when you add and binary, what you are saying is that each one of these x's have got a chance of appearing or not appearing. In other words, you got to remember that what you are doing is a binary constraint. So you add and binary. And then you will have a complete model. Yes, Abubakar. Abubakar, your hand is up.
But please, can you take the mutually exclusive one more time for me?
Which one?
The mutually exclusive.
Which one was a mutually exclusive?
I
mutually exclusive, but it wasn't that like that.
Yeah, the x1 plus x2 less or equal to 1.
But that less or equal to 1, that was the first one we looked at.
Yes, but I'm trying to say that we're still having difficulty in my mind to understand. Can you take it one more time for me?
Can. All means add.
Correct.
Can means that the answers are going to be, first of all, the right hand side is 1. So can means that it's less than or equal to. And you've already defined the whole thing to be binary. So if it is binary, it's going to be 0 or 1. So if the thing is less than or equal to 1, it means that you are saying that the combination of this can be 0 when it is the less than part, or can be 1 when it is the equal to part. So it means that when it is 0, which is a less than part, what you are saying is that you are not building x1, you are not building x2. But when it is equal to 1, it means that either x1 is 0 and x2 is 1, or x1 is 1 and x2 is 0. So the equal to part means one of them is being built. The less than part means none of them is being built. But when you look at the question, it says that either of them can be built, but not both. That is why we have to use. But we just don't know which one. And because we don't know which one has to be 0. We don't know which one is going to be 0. That is why we got to bring the less than or equal to part. Because one of them is going to be built. But when one is going to be built, the other will have to be 0. I don't know which one is being built, and I don't know which one is not being built. And so that is why I use the less than. The less than will indicate that, one which wasn't built. Then the equal to will indicate one which was built. Now you are even more confused, isn't it? Now, what if you have this constraint? Exactly 2 of the projects must be built. Exactly 2. The word exactly 2 means what symbol? Exactly 2. Exactly 2. Moses.
Say equal to.
Equal to. Equal to what?
Yes. So this means x1 plus x2 plus x3 plus x4 is equal to 2.
It is equal to 2. So that's one.
Thank you.
Now, no more than 2 must be built. No more than 2 of the projects. Remember, right now we don't know which project. That's why we have x1, x2, x3. No more than 2 must be built. What symbol is that? Or how do you formulate that? Zan. Tahiru, you are not coming to join us, and Tahiru. Have you joined the club?
I've been around since the beginning of the class.
Yeah, what I mean is that you are not joining the raising of the hands.
Oh, no, I've been raising my hand. I haven't been.
Okay, go ahead.
So that would mean x1 plus x2 plus x3, x4 is less than or equal to 2.
Okay. Yeah, that's true. As long as it's coming from your mind. That's true. That's one matter. That's true. Okay. Now, what if you have each swimming pool is very important and table tennis is less important? What does this constraint mean? What I have realized is that, okay, let me answer this. Let's answer this one. Each swimming pool is important and table tennis is less important, how will you write this constraint? Elsie.
So it will be swimming pool, that is x1 greater than x2.
X1 greater than X2. No, that's not. No. Abedina.
X1 is less than or equal to 2.
Why?
It tells us how it gives us the priority of it.
What priority? I'm only asking you a question to know that what you said you understood.
Yes, it indicates how essential for it to be the need for it to.
Because that option what you said is wrong, and I want to see whether you can still justify it. Because what you said is wrong. But if I had told you that is wrong, then probably you wouldn't have justified it. Because when you tell me that something is less important, it doesn't mean that it's not important.
Okay.
It doesn't mean it's not important. It only means that it's Mark.
Doc, x1 is greater than or equal to 2.
Why?
Because it states that x1 is very important.
I think somebody gave that answer before, right?
Yes, sir, I did.
Who is that? Elsie.
Femi. Yes, please.
That is the right answer, actually. The only thing is I wanted you to defend it, Elsie. I didn't say, oh, Doc, why? You didn't say, oh, Doc, why? Yeah, you should have said, oh, Doc, why? I didn't say that. You should have said that. So it is x1 greater than or equal to 2. Elsie, 2 marks. But next time you have to defend yourself. Okay?
Yes, sir.
Because other than that, I'm giving it to him. But I remember you. But if I had given it to him, you would have said, oh, Doc, but I said it, isn't it?
Yes, I would.
So that is when you should have said it that, oh, why? Why is it wrong? Because normally when you defend it, then I know that you know what you're saying. But when you don't defend it, then it's like you're taking it as an apostle somewhere. So once I said the thing is wrong, you see yourself, you're not so sure.
Yeah, so, I stated that. I stated that the swimming pool is more important than the tennis, so which means it is x2. X1 is greater than the x2.
Did you say x1 is greater than, or you said x1 is greater or equal to?
Greater or equal to
now you changed
greater. Say, like I stated it at first. Sorry.
Or you probably even said greater than, and I've rather thought that it's greater or equal to. Are you sure you said greater or equal to?
I said it.
You said it.
Yes, please.
Okay. All right. So that is how it's supposed to be, guys. You should know some of these things. Let's go to the last one. In fact, this is delaying me because the substantive matter is not started yet. What if swimming pool should be built if and only tennis must be built? That word must is an equality, so it means that the two must be equal. Okay. That is a co-requisite constraint. I mean, your hand is up. Aminatu, what's your question? Can you unmute her? Because I think she wanted to.
So she's dropped her hand. If she can raise her hand again.
Priscilla, your hand is up. Do you have a question?
Yeah.
Priscilla, I think I unmuted you, but you've gone again. Aminatu.
Yes, sir. I was about to answer, saying that x1 equals x2, and then you projected it.
I didn't ask for a question.
Oh, you asked before you projected.
Maybe you're enjoying the process, so your hand is up many times. Okay. Now,
can I ask my question?
Yeah, go ahead.
This is Priscilla. The one before that, why didn't we write it the other way around, that x1 is greater than or equal to x2?
This is the same as x1 greater than or equal to x2.
So you can write it either ways.
Yes, the same.
Okay.
All right. Let's go to there. So this is it. When you formulate all of this, you can then put it all down, and you can have this complete model for that formulation. And then finally, don't forget, you need your binary and integrality control. So you can see that here, I have incorporated this. So you can say that what you're seeing here, x blah, 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 greater or equal to 0, then you add or 1. That is binary. And it's also non-negativity constraining. Or you can just say greater than or equal to 0 and binary. Okay, the same thing. So take note. Or 1 or and binary. Okay. Now, this is the one that combines everything. Okay. So I'm not going to run the model. I'm just going to ask you. Nancy has $250,000 available for investment. Swala, what's your question? Swala, what's your question? Your hand is up.
Doc, yes, just the last slide you just ended with us. I just wanted some clarity there.
What is
so
the
we know the binary has to do with 0 and 1. How about just 0 between 0 and 1, I mean?
Yeah.
So what if we just have the constraint to read less than or equal to 0, 1?
What do you think
instead
about
of adding binary?
We've never had anything like less than or equal to. This is a non-negativity constraint. It would defeat the non-negativity part. Chief, how can you say that we need to have something like less than or equal to 1? When you say less than or equal to 1, can't you see that we can have non-negativity? You can't have that because you are forcing the thing to go below 0. Moses.
Sir, please, the other slide, when you check the table, athletics, you have 7 acres. You know, they have budget constraint at the same time land constraint. And that particular section is the highest acre of land that you are having. So if you are going to construct that facility, don't you think it will limit the rest of the facilities? Because I was wondering why that huge number.
Which?
Thank you.
12. The 12?
No, the 7 acres of land, athletics. 7 acres of land, when you check the table.
This one?
Yes, please.
And you're wondering why it is 7?
Yes, because you have a budget constraint and you have a land constraint. So when in that particular section, you have the highest value, which represents 7 acres of land. So I was asking, if you're going to construct that, don't you think it have a negative ripple effect on others, like other facilities?
Why wouldn't you do it? There's 12 acres. So if I use 7 acres out of the 12, am I now left with 5 acres?
Yes, please.
What is the problem? Can't I distribute the other 3 for the others? If I think that this one is important to me.
Okay. That's fine. Thank you.
All right. And besides, remember that some of them are not going to be built anyway. All right. Now, in this question here, Nancy has $250,000 available for investment. My interest is in the blue items. Nancy is either going to use that money to invest in building, land, and bonds. The question I want to ask you, simple. Which one can be non-negative? Which one can be non-negative? Which one can be integer? Bernard?
Use the bond.
The bond has done what? You have to talk English. When you say that, I've asked many questions, then you say the bond.
Okay, so bond, as in with the building, you can be specific on whether you're building 1, 2, 3. But with bonds, the amounts you are going to invest in them can have the decimals in them.
And then?
That is all.
We think about all the rest before you started talking about bonds alone. Let me give it to another person. Should have thought about all three of them. Yes, Tahir. Tahir has muted herself again. Actually, muted.
Hello, the integer. Oh, so the integer variable is the building. Then the land and the bonds can have decimals.
Yeah, why?
Why? So with the land, you can have several acres of land, and some of them can be more than a whole digit. So you can have maybe 1,000, 100 and something, point something. And with the bonds too, you can have non-decimal amount of money. But with the building, you can't have 1.5 building or 2.5 building.
Okay. So in this very example, the land can be decimals. And that is why you can see here, that's 2 marks by the way. So you can see that the land can be a decimal. That's why you just indicated that x2 is 0, is greater than or equal to 0, which means it can be decimals for the land. But then the x1 and the x3, which is the building and the bonds, okay, these are strictly integers. These are strictly integers. So even though they are non-negative, they are also integers. So that is how you can see that this very example has got both integers. So it has nothing to do with the question. This is where your mind must come to. You've got to ask yourself. See, if you don't take care, you might even think that land cannot be decimals. But you can have a quarter plot of a land. You can have half plot of a land. And all of these are decimals. So once you have that in mind, you will know that x2 should be non-negative, and that's it. Then you can now establish the integrality constraints on the first one. And as for building, it has to be pure whole numbers, and bond pure whole numbers. It's the number of bonds you're holding, not the amount of the bonds. Okay. So that's it. We're going to apply all of this now into the work. So at this stage, I'm going to unmute all of you because what we're about to do now is apply everything together. And this is where your mind must pay attention. So I'm going to unmute you. Just unmute yourself, please, so that we don't have too much disturbances. Because me clicking and unmuting you takes my time. Because I'm trying to move fast. Okay, let's start with the application of integrality constraint. I'm pausing. I want you to breathe in. I want you to take water. There is a problem known as a fixed charge problem. A fixed charge problem is a problem that can be solved. Oh, people were supposed to mute themselves. I never thought that people would never unmute themselves like that. I can't really believe that Lily Amwatin and Eunice Precious are not unmuting themselves. They are not muting themselves. They are just sounded. You know, people have not muted at all. Classroom.
Sir.
You yourself, you are not even muted yourself.
Sir, I've muted.
But you are not ensuring that people are muted. Should I still mute everybody now?
No, sir.
But if people are paying attention, then they should mute themselves. So why is it that they are paying attention, but they are not listening to what I'm saying?
So please, I think there was a mix-up. You said they should unmute themselves now.
Yeah,
So
that's
I
what
think
you
that's
said.
yeah, so I think that's where the mix-up was.
Okay, so mute. And especially for those of you with a noisy background, Macolac type of background, please, you there should mute that forever. Okay. You see, Sandra Siada has unmuted, even though I've told her not to. I don't think some people are really joining the class. What I think is that some people are doing certain things on their own, and they've left the phone somewhere, or the phone is in their pocket, and the phone is muting and unmuting itself. You know. Anyway, the end will justify the means. So what we are going to do is to look at a fixed charge. A fixed charge is a fixed cost. Let me just take you back to microeconomics. In the microeconomics, total cost is defined as fixed cost plus variable cost. What is the difference between fixed cost and variable cost? Fixed cost is normally drawn as a horizontal line, like this. Variable cost is normally drawn from the origin, like that. Going upward, this is cost. What is the difference between fixed cost and variable cost? Bernard.
So please, fixed costs can be incurred irrespective of the level of output. However, variable cost depends on the level of output.
Excellent. 2 marks. Ishmael, give me one example of a fixed cost. Real life example. Costa, give me one example of a fixed cost. Real life example. Costa. Ishmael, please mute yourself. Ishmael, mute yourself.
Rent paid in advance.
Rent paid in advance. Very good. 1 mark. Ebenezer, give me one example of a fixed cost. Ebenezer. Swala, give me one example of a fixed cost. Ebenezer, mute yourself. Ebenezer, mute yourself. Swala, give me one example of a fixed cost.
Cost of machines bought for production.
Machine bought for production. Very good. Very good. That is 1 mark for you. So you should know what a fixed cost is. It doesn't matter whether you are producing or you are not producing. That cost has been incurred, like school fees. Whether you study, you don't study, whether you pass, you fail, that school fees cost has already been incurred. So such costs are known as fixed costs. But then there are other costs which are variable. Okay? The other costs which are variable costs. Isaac Ahini, are you with us? Isaac.
Yes, sir.
Why have you unmuted yourself? All right. So you want to be able to understand the difference between the two because you're going to apply that pretty soon. In real life situation, there are certain things that are fixed. There are certain things that are possible. There is a trick of formulating a linear programming using a fixed charge problem. In such a fixed charge problem, there is a cost associated with performing an activity at a non-zero level. Guys, I beg you, what I'm about to teach you now, if a person is slightly interrupted by something, the person will not follow. I said it all the time, and people said, okay, we are paying attention, and we are. But then they get to know that slight twitching, and then they get stuck. So I beg of you, stop everything else you are doing, concentrate fully this last few hours. All right. So let's take a typical example of a storyline that will bring home the entire fixed charge problem. Tema, Textiles Limited. They produce 3 types of clothing: shirts, shorts, pants. Anytime you are producing each type of clothing, you need suitable type of machinery available. The machinery has to be available before you can produce. For example, if you want to produce shirt machinery must be available. In other words, you must rent it. You need to produce each type of clothing, you got to rent that machinery. If you don't rent the machinery, you will not be able to produce that particular shirt or short or pant. The cost of renting the shirt machinery is 200 every week. The cost of renting the short machinery is 150, and the pants machinery is 100. If you want to do this proper manufacturing, you also need the amount of cloth and the amount of labor that are shown below. So as an example, to produce shirts, you need 3 hours of labor time, and you need 4 yards of cloth. To produce pants, you need 6 hours of labor time, and you need 4 yards of cloth. Now, what are these things? So far, what are these? These are what? Resources that are used to produce the items in question. Now, each week, 150 hours of labor and 160 yards of cloth are there. They are available. The unit cost, the selling price of each type is here. Formulate an integer programming problem whose solution will maximize the profit of the company. Now, you have revenue. So the revenue, the sales price for shirt is 12 cedis, and the variable cost is 6 cedis. And the same way, when you take pants, the sales price, remember the sales price will eventually lead to the revenue, because you need the sales price multiplied by the quantity to get the revenue. And of course, it also has a variable cost. Now, who can tell me the formula for profit? Profit, represented by pi. What is the formula for profit? You all do economics. You all have done some management or accounting. What is the formula for profit? Profit is always what? SHS. They did this. What is profit? Henrietta?
Revenue less cost.
Revenue minus cost. So profit is actually total revenue minus total cost. Okay. Now, what is the total revenue? What is the total revenue itself? It's made up of what? Acidity.
Price times quantity.
Good. So the total revenue is the price multiplied by the quantity, okay, minus the total cost. What is involved in the total cost? The total cost itself is made up of what? The total cost, Nathaniel.
So it's unit cost times quantity.
Yeah, but itself is split into what? The total
So
cost.
it's the fixed cost plus the variable cost.
No, that's it. That's it. Okay. So it's a fixed cost plus the variable cost, but I want to expand the minus. I'll do fixed cost minus variable cost. Please, do you all understand why I did the fixed cost minus the variable cost? Because already there's minus in front, and when I apply that minus in front of all of them, it will be what? It will be minus minus. And other than that, it will be plus, it will be a bracket like this with a plus. Fixed cost plus variable cost. But when you apply the minus, I expand, then everything becomes minus. Okay. Now let's get now into the fixed cost. So this is the profit of the company we are maximizing. So we need to know what the total revenue is. But before we do that, we need to define the decision variables. So you're about to define the decision variables here. What are the decision variables? Let's go back here. How will you define the decision variable? How will you define the decision variables? Alan.
So please, there are 3 products here that we are talking about. So let X1 be number of shares produced each week.
Continue.
The number of shares produced each week. That is X2. Then X3, number of plants produced each week.
Very good. That's too much for you. Keep it.
Thank you, sir.
Now, this is how you define it. I like the way you use number of. In your view, all of you, this is not for you, all of you, in your view, what type of allocation will you give to these decision variables? Are they mixed? Are they integers? Are they pure integers? Are they binary? Are they linear? Non-negativity. What exactly are they? These short span, what are they? What will we talk about them? Are they pure integers? Are they binary integers? Are they mixed integers? Are they just non-negativity? What are they? Wisdom.
Yeah, Doc, please, I'll say they are pure integers.
Excellent. 2 marks. I'm dishing out the marks very quickly. So they are pure integers. Why? Give me a reason why.
They are pure because they all have positive whole numbers, meaning we can't. Then they are not binary because they go beyond 0 and 1, and then they are also not what's the name? They are also not. Please let me check. They are also not what's the name? The decimal one. Yeah. Sorry, sir, but you can't have decimal clothes. There's now a decimal number of clothes, shirts or shorts, and then there is some pants produced. They are positive whole numbers. They go beyond 0 and 1.
Very good. Very good. Very good. There is something in this question that is interesting. You're right. You're right. You got it 2 months. And that is a statement that was made, which I've highlighted here. It says that the machinery needed to produce each type of clothing must be rented at the following rate. So what this means is that, yes, Richard, your hand is up. Richard raised a hand. I don't know why he has lowered it now. Okay. So the machinery needed to produce each type of clothing. And so this is the one that the guy mentioned it. The machinery needed to produce each type of clothing must be rented. But here's the point, guys. You cannot produce shirts unless you have gotten the shirt machinery. Do you all agree with that? Do you agree with that?
Yes, sir.
Yes,
please.
Yes,
Yes, please.
So you got to make a decision. If you decide to buy shirts or to produce shirts, then you must also decide what? Who can raise a hand and tell me? If you decide to produce a shirt, then you must also decide on what? constant.
Right. You must also decide a shed, a machinery shed.
You must also decide what.
Okay, so if you decide to produce a shed, then it means that you must also rent a machinery that produces shed.
Exactly. That is two mark. You must rent a machinery that will produce the shed for you. Which means that the production of shed is contingent on the availability of shed machinery.
Yes.
Which means you got to decide on the shed machinery. So your decision variable is not on the excess, the shed, but it's also on the machinery for those clothes. You guys get it?
Yeah.
Okay, if you get it, that's fine. Now, so there are two decision variables here. And I'm going to represent the shed machinery as Y1. Where Y1 is the machinery I must decide, the shed machinery I must decide to rent if I'm going to produce shed. So Y1 will have to be equal to, and it must be binary. And see why it must be binary. Every fixed charge problem must have some binary. It's a matter of which one. It must be binary. Why? It must be equal to 1 if something and 0 if something. Who can tell me the 1 and the 0? It must be 1 if something and 0 if something. What is the difference between the 1 and that of the 0? It must be 1 if something. Eunice, Precious.
It must be 1 if the machinery is available and then 0 if it is not available.
No. It must be 1 if something and 0 if something. Bruce Echo.
Sir, it must be 1 if you rent the machine for the sheds and 0 if you decide not to rent.
And why would you decide not to rent? Why would you decide not to rent? Pastor Soda.
It must be 1 if you decide to produce shed, and if you decide not to produce shed, it must be 0.
Excellent, too much. Guys, you got to think along with me. You got to think along with me. If you don't understand, please ask. That's why I said that at this stage you should eat something. Swallow, your hand is up. So if
yes, I wanted. No, I wanted to, but
Master, don't be raising your hand by heart. If you have a question, then when you raise your hand, you ask. So if you decide that you are going to produce shed there, then Y must be present. That's the 1. Then Y must be present. That's the 1. But if you have decided that you're not going to produce shed, then Y must be 0. Absent, because you're not going to use it anyway. So we must have a decision variable for the X's, and then each decision variable for the X must also have a decision variable for the Y, the machinery for producing the X's. Now, on the basis of that, we are now ready to formulate the objective function. The objective function must be profit, which is total revenue minus total cost. Don't forget that. So profit is the total revenue minus the total cost. And the total revenue comes from the price times the output. So the profit is going to be what? Who can tell me? Just on the revenue side. is going to be what? Looking at the data in front of you. Remember, the profit is total revenue minus total cost. Total revenue is price times the quantity. So what is the total revenue for all of them for the TTL company? Tamaklo.
Okay, so the total profit will be, or total revenue will be 12x plus 12x1 plus 8x2 plus 15x3.
Okay,
That would
very
give you a
good.
total revenue.
Let's stop there. Plus 15x3. Question for you. Why are you multiplying each of them by the x's?
Because the x's represents the quantity of each of these items that you'll be producing.
And what are the quantities?
So the number of shirts to be produced, the
And
number
what
of
are they?
shirts. Come again.
What are they?
So those are the decision variables.
Yeah, so what is the value?
So unless I'm not getting your question correctly,
What
what
is
we define them as.
that
Come
number
again.
of produced?
Sorry, please take that again. I don't know if it's my
What
network.
is the value of that shirt produced? Number of shirts produced. What is the value of that?
So for shirts, it's X1. For
What
shorts,
is the value of
X2.
that?
I'm not too clear on the question, please.
You know you are not too clear. It's because I'm asking you a question that is eliciting your mental work. And you probably do not have an idea that you have to tell me that I can't tell you the value because we are yet to find, isn't it?
Okay, so that's what I was trying to explain, that as it
You were trying
stands,
to explain. You should just say
value.
of the value because we are
Okay.
yet to find them.
Okay,
So now you
understood.
just repeated by saying that you are not getting the question. You get it.
Understood. So what I should have said is, as it stands, because we do not know the final value, we are representing it by X1.
Because I'm asking you that question to be sure that you know what you just wrote, not that you pick it on somewhere.
Right, understood.
Yeah. I would have given you the mark, but now I will need you to come back again. So that is the objective function for the revenue part. Guys, if you don't understand parts, let's go to the cost. Remember, it's total revenue minus total cost. The total cost must start with fixed cost and variable cost. What are the fixed costs? Let me just go here. How will you write a fixed cost? What to be the fixed cost? And I'll ask you a question. So then just, what to be the fixed cost? Richard, me, the fixed cost.
The fixed cost would be the money used to rent out the machines. To rent the machines.
Sorry, can you come again?
I mean, the fixed cost is the
Tell me the
amount used.
Tell me the question for that.
Okay, good. Listen.
Let's go to another person. When you thought that, then you come back, okay? Because I thought you've done it. That's why you raised your hand. Elsie, tell me the fixed cost equation.
So the fixed cost is actually the price allocated for the type of clothing, the machinery to be rented. So the shirt machinery will be 200 per week, and then the shorts machinery will be 150, and the pants machinery will be 100.
How will you add this fixed cost to the profit function? How will you add it here?
How would we? Okay, so it would be minus.
So she writes minus
200x1.
200x1.
So is it possible if you could bring maybe a bracket before?
Okay, I brought it.
No, before the, okay, yes. So 200x1 plus 150x2 plus 100 x3.
Did I close the bracket, by the way?
Sir, please close it for now. That is for the fixed cost.
Okay. But the only thing I was asking was for the fixed cost too. That was the only one I was asking you.
Oh, okay.
So the way you said for now, it's like you come back again. Are you coming back?
No, sir, I thought we'll be adding the variable cost.
No, I said fixed cost. I didn't say variable cost.
Okay.
Sir, please, I have a question.
Are you done? Elsie,
Sir.
are you done?
Okay. So yes, for the
Okay,
just
okay.
an answer to the first course, yes.
All right, so that's wrong. So I'll wipe that away because it's wrong. Who will correct it for the first course? And whoever is correcting, I'll ask you two questions. So you got to have a deep knowledge of why you are correcting it. Okay, it's not you picking it somewhere and giving it, but you have to have a deep knowledge of why you are mentioning it to me. Okay, Pakra, Jan, you've not spoken today.
Yeah, so I think her answer, you changed the x's to y's. So it's minus into bracket.
I need to know why.
200 y. Okay, because the first cost, the y is saying is 1 if we are going to produce it, and 0 if we are not going to produce it. So you put y there because it's a decision variable.
Why? Why should I put y there because it's a decision variable?
Because we are yet to make the decision on whether we are going to produce or not, and that is based on a quantity of x.
I need a proper conviction, unless they understand. You guys understand? Because it's easy to see that answer somewhere and tell me what you are telling me. Do you know that?
No, so because it's a fixed cost, we are not using x because we are not going to multiply it by the quantity.
I know.
We are going to multiply
it by the y's. But I'm saying that
yes,
why do I have to multiply? Why don't I just write 200, plus 150 plus,
okay,
that is simple.
So the y is binary, either 1 or 0. So if you are going to produce 1, making the first cost apply. But if it's 0, then the first cost does not apply. That's the cost times 0, which is 0.
The fact that your colleagues' hands are up means that they don't get your clarity. They are raising their hands too much. Deborah,
Hello, sir.
Yeah.
So it will not be a wise business decision to rent a machine that I wouldn't use. So we add the variables because the variables are a decision of whether we are going to produce the particular clothing or not. So we would have to add.
Established. I thought you were going to say the variables are a decision of whether we are going to rent or not.
I don't get you, sir.
Me too, I don't get you.
Okay, so you cannot just write 200 plus 150 plus 100, because if you write it like that, it means you are telling yourself that you are going to incur those costs, and nothing is going to nothing influences your those costs. But those costs are dependent on whether or not. So, for instance, if I decide not to produce shirts, I'm not renting a shirt machine.
So you say those costs are dependent on production, Abby?
Yes, please.
But then the person who wrote it and added the production element, which is the excess, we said it's wrong.
Yes, it is wrong because if I'm producing, whether I'm producing 1 shirt or 100 shirts, I'll rent the machine. So if I add X, it makes it wrong because it is fixed. It is not influenced by the number of shirts I'm going to produce. So if I rent the machine, I may produce 10 shirts or I may produce 200 shirts.
Good.
And that is not going to be influenced by whether I'm renting the machine or not. The machine will be there, and then the shirt product.
You're right. I know the answers you guys are giving. I'm only pushing you guys to the wall. You know that. To explain why you are giving those answers. Because that is why, as one of you is explaining, the other is thinking. Then the person gets a better understanding. Then that person now even want to explain and join the crowd. So why do you say that because they depend on the X's, that is why we need to attach it? But I didn't say they depend on the machines. Why?
Please, for which of them, please?
Okay. Why are you attaching the Y's?
Okay, so I'm attaching the Y because the machine will cost me 200 cedis. If I decide to produce a shirt, Y, my decision variable Y is whether I decide to produce a shirt or not. So if I decide to produce a shirt, which will be 1, it means that my 200 will be 1. So it will have a value.
That's wrong. You can't say when I decide to produce a shirt, which is 1. You're mixing it. Because shirt is not going to be 1.
No, as in, I'm not saying like 1 shirt. As in my decision whether to make shirts or not. As in that binary is what I'm talking about, not the number.
That's why I'm saying that binary explanation you are giving is not for the shirt. Okay, hold on. Let somebody come in and then probably you'll get a picture. Guys, I need the last person to crack this thing well for me because I'm going around too much. I mean,
Sir, please, can I say that you have to pay the rental weekly regardless of the output you get. So that you must, by all means, rent the machine weekly.
I agree. Regardless of what you produce, I agree with that one too. But why are we not attaching X1, but we are attaching Y1 to the first one? That's my question. Why are we not attaching X1, but we are attaching? Some of you are getting the ideas, but the way you're explaining it, you got to convince me. Kaka, your hand has been up.
Yeah, so I think the Y is the decision to rent or not.
Exactly. Then why is the decision? So you got to take out that X part, whether I produce or no. We are writing 200. When you write 200, that 200 is the cost of shirt machinery. Okay, is the cost of shirt machinery. But the reason why we are attaching the Y is because we are renting. We are renting a machinery, and that machinery is a Y. We happen not to rent the machinery. So the conversation should be more about the machinery than about the shirt. If we decide not to rent the machinery, then we are back to the 200. Sorry, if we decide to rent the machinery, then we are back to the 200. If we decide not to rent the machinery, that 200 is 0. So attaching the Y wouldn't change the result of the 200. If you happen to actually incur that 200 cost, you're only multiplying the answer by 1 because Y is 1 or 0. So the presence of the 200 requires the presence of the Y, the machinery itself, before you talk about its cost. It is the machinery. Before we talk about its cost, it is the machinery before we talk about its cost. Okay, so, I mean, this is for all of you to understand. It's not to generate math. So we are attaching Y1, Y2, and then Y3 to each one of these. And then we will add the variable cost. But remember, when you're adding the variable cost, there's a minus. Okay, so you are going to add the variable cost to it, which will also be part of the minus. So it's minus the variable cost. And the variable costs, what are they? You come to the variable cost. You come to the substantive matter. So I just need you to get this one. The variable costs are 6, 4, and 8. So now when you do that 6 and this variable cost, remember the word variable means they depend on the level of production, which is the X's. So you're going to get 6x1. I want you to do something for me here. So get ready. 6x1 plus 4x2 plus 8x3. Now, what will be the final profit function? Somebody should give me the complete simplified final profit function. Raise your hand and walk me through. Please do it in your head before you raise your hand. The complete final profit function. Complete final profit function. I'm giving 1 mark for that. Constant. Harry, constant.
Okay, so the complete final profit function will be 6x1 plus 4x2 plus 7x3.
Okay. Plus 7x3. Yes.
Minus 200y1 minus 150y2. So the last value minus.
So you are the people who don't write it.
Yes, minus 100y2. Yes.
You are the people who don't write the things down when we are talking. That is good. 1 mark for that. Okay. You are supposed to be writing it. You see, what I just wrote, and you are all seeing, you should be writing it for yourself to be seen. So this is your complete model. This is your complete model that you have here. And this is your objective function. Subject to the first constraint. What is the first constraint here? What is the first constraint? Who can formulate the first constraint for me? Bruce Echo. Formulate that for 2 marks for me, quickly.
Labor constraints. So it will be 3s1 plus 2s2 plus 6s3 less than or equal to 150.
Very good. 2 marks. And then the float constraint. Who will formulate the float constraint for 1 mark for me? Martha Esel. Martha,
Sir, please. Sir, it's 4x1 plus 3x2 plus 4s3 is less than or equal to 160.
Very good. Very good. Excellent. That's 1 mark. Now, what other constraint do we need to have? What other constraint do we need to have? Paul Newman. Moses Allen.
Non-negativity constraint.
Okay. What is that?
Set x1, comma, x2, comma, x3 is greater than or equal to 0, an integer.
And what?
Integer. I got the word. Oh.
Okay, very good. That's 2 marks for you. Now, what other constraints?
Thank you, sir.
What is the next constraint? What is the next constraint? Eric Edu?
The rental of the machine is binary, so y1, y2, y3 is binary, or it's equal to 0, 1.
Eric, did it come from your head?
Yes, sir.
Be honest with
I actually
yourself.
got confused at a point, and I wanted to ask a question, but someone made it clearer for me.
So this came directly from your head?
Yes, sir.
Okay, what's your question? You have 2 marks, by the way. What's your question?
Sir, I got confused at the point, and I said I wanted to ask a question,
If
but
you are sorted,
someone
that's
followed
okay.
up.
Or
Yeah,
you
it
still
was
want to
sorted.
ask the question? You are sorted.
No, it was sorted. Because when it was Elsie said X, I was confused why fixed cost was going with X, but it was clarified.
All right. Now, this has to be added to your constraint, because if you don't add this to your constraint will be wrong. So let me show you guys something. Show you guys something very important. So everything we have done is just formulation. You see, one interesting thing about a fixed charge is that you don't need to solve the model. You just need to formulate, and that's it, 25 marks. Take note. That is why I'm being detailed about it. Once you can formulate it, you're done. So this is it. You have your constraints, and then you can add this. Okay. Now, what is the problem with this model? There is a problem with this model. It's been well formulated. There's no doubt about it. It's been orchestrated beautifully. There's no doubt about it. But there is a problem with this. If you don't know, don't worry. I'll teach you. That thing, in fact, it's difficult to actually detect unless you've actually read the entire note and you have it some sort of in front of you, where you make it like, but if you could detect, yeah, Moses, your hand is up.
Sir, please, we are not seeing the Y's, we are only seeing the X's.
You've read the notes, isn't it?
Yes, please.
So it's good. It's good when you have it, now in front of you. Sometimes I want you guys to just think, so that it will be much more poignant. Because if you have the answer in front of you and you tell me, normally it's not that poignant. It doesn't, you don't challenge your mind. Now, but that's good because at least you have found it somewhere. I'm not saying that everybody should go and still see things. That's good for 1 mark. When you see this one,
thank you, Doc.
When you see this, okay, look at it carefully now. The constraint, the decision variable, the function has got y in it and it's got x in it. So the x's are there. Please mute yourself. The x's are there and the y's are also there. But when it comes to the constraints, only the x's are there. There's no y in any of the constraints. Look at all the constraints. There is no y. Forget about the integrality and the non-negativity. There is no y in the constraint. In other words, there is no linking constraint. There is no relationship linking x and y. And we need that linking constraint, guys. We need that linking constraint. Anytime you are formulating a fixed charge problem, you need that linking constraint. And what is a linking constraint? The linking constraint is always what I'm about to show you. Every xi is less or equal to mi yi. Write it down. Write it down. Every x1 is less or equal to m1 and y1. Every one of it. Everyone. In fact, this model, if you go and solve it, this is what it will tell you. The one we just did. If you solve it, this will tell you what is the problem with this answer. If you solve it in Excel, you'll get this answer on your screen. What is the problem with this answer? What is the main problem with this answer? There is a problem. Look at the answer carefully. There is a problem. What is the problem? Y1, Y2, Y3 are 0. Aminat.
Sir, please, you can't produce with 0 cost. You by all means incur cost to produce.
So where is the problem itself? Pick the problem.
The 0.
Oh, be specific. Yeah, be specific. Be explanatory now. Let's go to another person. Okay. Normally, Joel Mino.
Sorry. Here it shows that y is equal to 0, meaning we are not renting anything to produce. So it's wrong.
Why is it wrong? Come on, you're not just telling me.
No, because we need to rent to produce. It's dependent on renting.
Okay, I can't talk back to you before you tell me the reason why you are saying. You got to be so precise, explanatory, and clear. Yeah,
it can be 0 cost of renting.
You are renting to produce, so you need to incur costs at the renting end.
Yeah, what?
You are renting machinery to produce.
Be specific. Pick on them. Pick on some of them.
Okay, so I need to look at it. Y1, Y2, Y3. I'm coming. That is as you look at the topology. Okay, so let me use shirt. You need to rent a machinery to produce shirt, and the equation here is equating it to 0, meaning that you're not renting anything, which is wrong. So you need to basically rent to make a production for shirt.
What will indicate that you have rented? What will indicate that you have rented? Antobre.
When y, any of the y is equal to 1.
That's it. Master, you see, that's the answer I needed. That answer would have told me that you know exactly the explanation you are giving me. When y1 is 1, then x1 can be 30. But y1 is not 1. You see, that's how you answer. Y1 should be 1 for x1 to be 30. So if you tell me that x1 is 30, but y1 is 0, it doesn't matter. That is a specific example I wanted. What's the name of the guy? Do you understand, Opele?
Yes, sir. Yes, sir. I get it.
But when you say you're not renting, you know, that one you're speaking in the air, you're not renting. And so I want to pick on one of them. So I'm giving you 1 mark, and the guy who's gave me that great answer, he should take the other one. Okay. So when you solve this thing, you get these results, which is a problem. So here is a linking constraint. Here is a linking constraint. Guys, pay attention here because it gets a bit abstract here.
Before you go to the linking constraints, the M1, what does M1 mean?
Excellent. This is what I'm coming to.
Okay.
I'm coming to that. So I gave you a constraint that always x1 is less or equal to M1 y1. And I'm taking shirt as an example. You can take pants or you can take it. To be able to appreciate what M1 is and what X1 is and what Y1 is, first of all, M1, first of all, you should know that for X1 to be positive, Y1 must be 1. Do you agree with that? All of you?
Yes.
Pay attention here. If you don't understand us, for X1 to be positive, okay, Y1 should be equal to 1. Do you all agree?
Yes.
Mathematically. What does that mean in English? What does that mean in simple English? It means that, yes, it
means that in order for you to produce X1, you need Y1.
Exactly. 1 mark for you. Now, keep that in mind. Now, so it means that if I am going to actually produce, I will need that machinery that will help me to do the production to be there. I will need that machinery to be present. It has to be there because the value of the Y can be determined from the X's. In other words, I cannot say that I am having an X that is positive here. That's when I say I'm having an X, I mean this is positive. When I don't know Y. So there is a connection between the X and the Y. But the question is that, what is the M? Now, first of all, when you look at the value here very carefully, if I am producing X, okay, and that is X1 is positive, what is the maximum value Y1 can take? What is the maximum value Y1 can take if I'm producing X1? What's the maximum value Y1 can take? Anim?
I think 1.
You think it is 1? It is 1 because Y1 is binary, is either 0 or 1. So the maximum Y1 can take is 1. Okay, so now pay attention. So if this Y1 here is 1, you multiply that 1 by the M1, okay, then it means that X1, okay, now X1 is the amount of shirt you can produce or the amount of that clothing you can produce. You can produce as much as possible, but there's a limit to which you can produce. So if Y1 is there, it means you are producing. So M1 now becomes the maximum value that X1 can be. I'll take it again. If I am producing, because Y1 is 1, then I'm producing, so X1 has to be produced. The maximum value that X1 can be, the maximum amount I can produce is that M1. So M1 is a trick. So M1 is a value, one of the values of X1, but it's the maximum of the value. We call it the upper bound of the X1. The upper bound, the maximum value that X can be. Of course, on condition that Y is there. On condition that Y is there. Because if this one is there, the less than or equal to part means that this X can take many values, isn't it? The less than part, watch it, guys. If you have X1 less than M1, it means that there are several values of this X's that are below what? M1. The equal to means that at that point, X1 is equal to M1, isn't it? But then it also means that there are other X1s that are below M1. Do you guys agree? Are you with me? Are you with me?
Yes, sir.
No, sir.
Then open your eyes. Open your eyes.
Yeah, I agree.
And listen with your ears. Look at this one alone here. This very one I have here. Just look at this alone. This value here means that if I have X1 is less than M1, it means that there are values of X1 that are below M1. Do you agree with that? Do you agree? Respond, let me move.
Yes.
There are values of X1 that are below M1.
Yes, sir.
But then, if you have X1 equals to M1, it means that there is one particular value of X1 that is equal to M1. Right. But the top part means that there could also be other values of X1 that are below M1. Therefore, M1 here is the maximum value X1 can take. It's the maximum value X1 can take, which means the other values. So you got to bring that. Now, how do you know these maximum values? You can only know the maximum values by looking at the constraints. That's all. You can know the maximum value by looking at the constraints. Let's go to the constraints. To ensure that we are producing X1 when Y1 is 1, okay, we need to find M1. And everything about the M1 is what I've just shown here. So let's go to one of the constraints. Let's take, so to get M1 for X1, watch it. I'm going to find this. X1 less than or equal to M1 is Y1. The same way I'll write X2 less than or equal to M2, Y2. Now, if I want to find this M1, I need to go to the constraint. Watch it. If I go to the constraint, there are only two constraints here. For each one of them, I'm going to find M1. But how do I find M1? We have already said that M1 is X1 value, that is the highest. Okay. So I need to find in this equation, labor constraint, I need to find X1 when the other X's are 0. Because it's X1 I'm interested in. So here, I'm interested in X1 here. And I need to set it to equality because I want the maximum. So I'll set this whole equation to equality. That means that I will have 3x1 plus 2x2 plus 6x3 equal to 150. If I set the other two, x2 and x3 to 0, then it means that we are going to have 3x1 equal to 150, isn't it? So what is x1? What is x1? Elsie.
150 divided by 3.
Oh, Elsie, I didn't want you to tell me that. How can you say 150 divided by 3? I knew that already. I just want you to give me the answer.
Hello, sir.
Yes.
Please, I was not the one who answered that.
What is it?
You mentioned my name, but I was not the one who answered. I just wanted to be clear.
Who answered the question?
So I thought I didn't know my microphone was on, so I was doing the division. Sorry.
Oh, no, but you should have done it before you raise your hand. Remember, we are working with Cornelia.
50.
50. So now X1 is 50 in the labor constraint. In the labor constraint. What is X1 in the cloth constraint? What is X1 in the cloth constraint? Raise your hand and tell me. Emmanuel Akono.
Please, so X1 to be 40, please.
Okay, so you have X1 to be 40. Okay, that is when you assume that X2 and X3 are 0, X1 will be 40. So the first one, X1 is 50. The second one, X1 is 40. We need to take one of them. Which one should we take? Of course, you must have a reason for that. If you guess, you are wrong, because I'll ask you two questions. Because when you just say that, we must take this one. Which one should we take and why? Michael Kosisapa.
Okay, please, we must take 50.
Why?
Why? Because we are looking for MY is the highest among the X1s. The 50 represent the highest among the two X1s.
Okay, very good. Martha, do you support? Michael, do you support?
Yes, sir.
Abu Bakari, do you support?
Yes, sir.
Yes. Yes.
Emmanuel, do you support? If you
Yes,
support,
sir.
your hands. If you
Yes,
support,
sir.
lower your hands if you support.
Yes, sir.
So I have a question.
I said lower your hands first before you talk about can you have a question? Yeah, Moses.
So please, 40. Because 40 is the smallest and it satisfies both constraints.
Okay, so it's supposed to be 40 and not 50. Moses, that's too much for you.
Thank you, sir.
Why? Guys, for you to take, even though we are X1, M1 is the highest value X1 can take. Between these two, the M1 is the lowest value. Because the lowest value will usually satisfy the two constraints. Why? Because if you put the 50 here, suppose you delete this, because they are going to be 0, and you put the 50 here, okay, it's going to be 3 times 50, which is 350. That will satisfy the labor constraint. But if you put the 50 here, it will be 4 times 50. That will be 200. That will not satisfy this second constraint. So 50 will not work. But if you take the 40, okay, 40, 4 times, for the second constraint, 4 times 40 will be 160. That will satisfy the cloth constraint. But what about when you put it here? When you put it here, it will be 3 times 40, 120. 120 will also satisfy the labor constraint. So therefore, the M1 is going to be what? Is going to be the 40. That is how you attack this. That is how you find M1 for this linking constraint. So now that you have found the M1, you come and rewrite the whole thing. So now you rewrite the first linking constraint as X1 less than or equal to 40 Y1. That is how you write this constraint for this one. I'm going to do the next one with you. But Emmanuel, your hand is up.
Yes, sir. So in one of your earlier slides, you mentioned that M1 should be the upper bound.
It should be the maximum value that X1 can take.
Okay.
So is
okay.
a bound value of the X. In other words, when you take all possible X values, the highest one will be the M1.
Okay.
But I didn't say that the highest one among your constraint equations you will solve. So if you look at the constraint equations we solved, one of them gave us 50, one of them gave us 40. But the 50 is not the highest one. Because for you to be highest, you must also satisfy the two constraints. You cannot go past the available. So when we put the 50 here, okay, it went past the available. The availables are here. Okay. When you put the 50 here, okay, when you put the 50 there, 3 times 50 gave us 150. But when you drop it here, it gave us what, 200. So it wasn't satisfying the cloth constraint, but it must satisfy the constraint.
Okay. All right.
We have
that
only
means M1 should be upper bound and satisfy the constraint at the same time.
Oh, yeah. It's the highest value that X1 can take. But where is it coming from? It's the highest value from the equation. From the equation, the constraint, the objective, everything is coming from it. It's the highest value X1 can take. So you can't pick it from anywhere and say, oh, X1 is a upper bound everywhere. No. Within the equation you are looking at. Within the equation. Let's try and find the second one. It will help us. So we are going to find X2. X2 is less than or equal to M2, Y2. How will you find the the M2? How do you find the M2? First, yes, Abubakar.
No, please, you've answered the question already. So I wanted to find out that I should settle both, but you've answered in your response. So thank you.
Okay. So to get M2, what you will do is that you will assume that in this equation and in this equation, X1 and X3 are both 0. And then you solve for the X2 value there. So it means that this, when it comes to equation 1, this and this will be 0. So X2 will be what? Who can tell me? You can tell me.
75. Sorry.
Henrietta.
75.
Go 1 mark for that, okay? So X2 will be 75. Okay. Now we go to the second equation. X2 will be what? Paul Newman.
53.3.
53.3. So X2, you got 1 mark as well. It's 53.3. Which one should we take? Which one will be the M1?
That's the answer.
You got 1 mark already. It's not for you. Okay. Which one should we take? Vida.
Sir, S2. Sir, please come again. Please come again.
Hey, but your hand is up. So I thought you knew the question. That's why your hand is up.
Yeah, it was asked for the 75. It was asked for the S2 is equal to 75. You didn't
lower it. I think you haven't lowered it.
Oh, okay.
Because you're asking a new question. Precious.
Okay, sir.
53.3.
Okay, why?
Because when we take the 75, the second constraint, the value for say 3 times the 75 will be way bigger than the 160, and that does not satisfy the cloth constraint.
Lovely.
But when we take
yeah. That is too much. Okay, so we are going to take X2 as our M2 now. Okay, now I want you all to work for M3 and tell me the value. Raise your hand when you have worked for M3. Work it, not pick it. Work it, not pick it. Because you can't work it immediately like this. Erica Du and Ponima. Or when I said work for, then all of a sudden you raise your hand. It doesn't work that way.
Well, whilst people are submitting for the 2, I was working the 3.
You were preparing for the next one, eh?
Yeah, so.
Eric, tell me your answer.
So it's 25 or 40. So the first one, if you assume X1 and X2 to be 0, then X3 becomes 25. And then the second one is 40. But I'll pick 25 because it satisfies both constraints.
Excellent. Very good. You got 2 marks for that. Okay. So that is your M3. So now that you've gotten these, you have to plug them all back into your final equation. And then you're going to get this beautiful final answer. So you substitute all of this, and then that will give you all these workings I did here. They're all there. Everything I did here. And this will become your final answer. So all that we had to do was to just substitute these. Substitute it. So we just added these ones. We added these ones. And now we have our complete final model. If you should work this in Excel, this is the answer you're going to get. Watch it. It's very, very strange and yet beautiful answer. Okay. You're going to get the answer to be this. You're going to get Y3 to be 1, and then X3 to be 25. Nothing else. Nothing else. Nothing else. And when you put it all into the Z function, you get 75.6. So it means that you should not produce anything apart from pants in this TTL. Amos, your hand is up. Deborah, your hand is up.
Sir, please, I want to find out. We got 53.3, but I realized that you approximated it to 53.
Yeah. Yeah, I did that. I did that for simplicity's sake. But the Excel will not do that. But I did that for simplicity. You can keep it as it is.
Okay.
Or you can round it. It won't hurt anyway.
Sure. Thank you.
Any other question from any of these that it wasn't clear to you? Let me know so that I go over that part. Because that's it. That's it. So if you weren't clear with a particular one, you raise your hand and then I clarify that. Deborah, your hand is still up.
Sorry, say.
Yeah. What?
If you have several constraints, we went for all and then we picked the lowest one. But I was thinking, so what if maybe
all the equation?
Yes. So what if the equality sign is greater than, for instance, if you are using these two, I believe 50, if we maybe the first one we work, I believe 50 would have been the ideal solution for M1 instead of the 40. So what if we have different inequalities varying between? So here we have less than or equal to for all. What if we have less than, greater than or equal to at one point and the less than or equal to at the other point?
As long as that one satisfies all the constraints, that's the one.
Okay.
Just have it in mind that one of them will satisfy all the constraints. The others will satisfy all but one.
Okay. Thank you, sir.
Any other questions?